No?
সার্কুলার এটা ম্যাম ঠিক মানে খেয়াল নাই আর কি।
Okay.
সার্কুলার এটা যদি আরেকটু ইয়া করে দিতেন ভালো হতো।
আবার আচ্ছা ঠিক আছে বলতেছি। So circular এতে যেটা হয়, okay. So what happens in circular array is the difference between linear array and circular array is that for linear array, it's a must that you start from 0. Like the initial value or the first value has to be in index 0. There's no alternative for that. There's no alternative for that, right? But for circular arrays, we can start from any index. That is, the first value can even be here. One sec. The first value can even be in the third index, or in the second index, or the first index, or even in the 0th index. So it's like a circular form. It's not a linear form. That is, if I consider it like this, this is basically a circular array. So that is, let's say 10 is here, 20 is here, 30 is here, and this is basically the starting index. So if I started from 3, so let's say this is 4, this can be 0, then 1, then 2. But we are starting from 0. So it has a circularity here. Okay, so the starting index can be like any of the other indexes. 0 hote parbe. So that's the main difference between linear array and circular arrays. So what we did in the last class was how we can iterate a circular array. So whenever we were iterating a linear array, we were always starting from 0, right? That is, we were starting from I, we were going up to size or the length of the array, and inside we were printing the values of the linear array. But as circular array can start from any index, that is, let's say for this example, let's say the first element is in index number 3, and so on. If we are starting from index 3, so if I'm trying to print, let's say, circular of k, so k is the starting index here, it's starting from 3. Then we are going to index number 4. So if we just do k is equal to k plus 1, then we move to index number 4, then 20 gets printed. But after that, when we again increment k by 1, it becomes 5, right? Right?
Yes.
And the index goes out of bound. In that case, what did we do? So that it circularly, the second index comes here. Like after
We
4,
divide
the
it by,
second.
we take the mod of the length.
Here we go. Right. So we, after incrementing, we were taking the remainder of k plus 1 divided by length of circular array. In that case, whenever it becomes 5 or more than the length, so 5 mod 5 would give us 0. And after that, if it becomes 6, so 6 mod 5 will give us 1, and so on. Right? মনে পড়েছে একটু?
Yes ma'am, মনে পড়ছে।
But the loop would run size times. Like I won't change the loop. The loop will be controlled by the number of, like, how many elements are there. But the iterator or the like the index will be manipulated by k, which will start from the starting index and will increment it by 1 by then length দিয়ে আমরা হচ্ছে mod করব. But the loop iterator will be I. So we also coded this. Okay, so this is backward iteration. So for this, we took a circular array which was starting from the 4th index. Then it went up to, like, the size was 4 because there were 4 elements. Then k was starting from the start. This is backward iteration, by the way. K was starting from the starting index. The loop was the same. Size would control the loop. So it would start from 0. It would go up to size. It will print the value of the K index, and then we will increment it by 1 and mod it with the length of the circular array. Clear? So this was the first thing that we learned in the previous class. The second thing we learned
Ma'am, can you
was...
please show the code again, please?
This is backward iteration, by the way. This is not forward iteration. So for forward iteration, K would like start from the starting index. Everything will be the same. Instead of this, K will be incremented by K plus 1 modulus of length. This is forward iteration. Everything else will be the same. So in that case, first 50, then 60, then 10, and then 20 will be printed. As this is backward iteration, first 20, then 10, then 60, and then 50 is being printed. Okay?
ম্যাম আগের ক্লাসে বলছেন যে এই কোডগুলো একটু দিয়ে দিবেন।
হ্যাঁ, আমি
কি পাইনি।
weekend আমি একটু sick ছিলাম. I could not answer to any of your queries, could not do anything actually. So I'll do that by tonight. Sorry for the delay.
জি ম্যাম, থ্যাংক ইউ।
Okay. Okay. Clear, right, everyone? Now if we backward iterate, তখন যেটা করছিলাম, what did we do? The thing that we had to remember was what? What is the last index? How do we find out the last index in a circular array? That is, if it's a circular array, the last index is 1, right? It has the last element. How did we find that? You remember?
Start plus size minus 1.
Very good. Start plus size minus 1, then
The mod of
Mod of length.
length of circular.
Exactly. So this is basically what we did here, that we were starting from the last index and we were decrementing K by 1, and as soon as K became less than 0 or became negative, we made K the last, like the length A minus 1. So whenever it like decremented from 0 and became negative, so we manually made it 4, and then it would decrement again. Okay, so that is the backward iterations. Another thing that we learned was, the last thing that we learned in the previous class was next available position. That is, what is the next empty position where we can keep values? For this one, it was index number 2, right? That is the last, that is the next available position or an empty index. How did we find that? Start
Plus size. Mod of length.
Okay, done with the recap. Everybody understands? So these are the basics of circular array that you have to remember. And after that, whatever we do, we will just use these things. How do we forward iterate? How do we backward iterate? And if we know the next available position. These are the ideas that we need to have. Do we understand circular array now? Shall I proceed?
Yes, ma'am.
Okay. So the next thing we'll see is that how we can convert a linear array to a circular array. And how we can convert a circular array to a linear array. This is also called, like this process is also called linearize. So let's say if I have a linear array, which looks like this. And so on. And if I create a circular array from this one, and the start is, let's say, defined. Let's say the starting index will be 3. So how will we copy the values from the linear array to a circular array? Do you understand the question? So this is a linear array. We are making a circular array from the values of the linear array. And the starting index is 3 for the circular array. So that means the first element of the linear array will come to the first index of the circular array. Do you understand the idea? So that means the value that was in index 0 in the linear array will come to index 3 here, 10 will come here, 20 will go here, 30 will come here, and 40 will come here. Gucci, understood?
Yes, ma'am.
Yes, ma'am.
So how are we doing? It's basically the same as how we were forward iterating. Basically, the loop would go from I till size. I till size, and for a circular array of k, we would copy the value of linear array's ith index into the circular array kth index. So k will start from the start. So basically, then k will increment like this, just like we did previously. Value in the first index is coming to the fourth index of the circular array. K is becoming 0 in the next iteration. I is becoming 2. So 30 is coming in the 0th index. Make sense?
Yes, ma'am.
So what we are doing is we are creating a circular array and we are copying the values from the linear array to the circular array. Clear? Okay. What's important is the next one, which is converting a circular array from the linear array. We'll need it for another concept later. So let's see that. So let's say circular array is, this is a circular array, let's say. This is the start. If we make a linear array from this one, what's happening? How do we simulate it? Do we just copy the values directly like this? Is this the right way to do it?
No, ma'am.
So what do we do?
No. We start at the 0th index for the linear array.
So for a linear array, we start at the 0th index. That is 10 will come here, 20 will come here, 30 will come here, and 40 will come here. Do we understand this? Everyone?
Yes, ma'am.
Because for linear array, we must start from index number 0. So it's the same basically. Again, k will start from the starting index. We run the loop from I to size, like in range size. And then inside, and we increment k the same way. Okay? Hope everybody's clear. Questions, anyone? This is also called linearizing or linearize. That we are making a linear array from a circular array. Everybody clear?
মিস k+1 mod len এটা কি লিনিয়ারের জন্য তাই না লেনটা
Linear length of the circular array.
সার্কুলার
So why do we need this? We need this for the next topic, which is resizing. We did resizing in linear array as well, right? So for circular array, let's say, and the array is full, or the size has become equal to the length. So 10 is here, 20 is here, 30 is here, 40 is here, 50 is here. We have no more space left. This is the starting index. Now, if we want to insert or do something else, we don't have any more like space left, right? So this is a compact or a full array. So if I need to insert something again, I have to resize, right? We understand that concept of resizing, right?
Yes, ma'am.
So for resizing in circular array, there are two ways to do it. One is we can resize by linearizing, or we can resize by keeping the start unchanged. Let's see both the ways. So for linearizing, we do this the same way. That is, we make a new circular array which has more length, let's say. Okay, so you're making a bigger circular array, and when we are copying the values to resize, we will resize by linearizing. That means the first element or the starting index, which was 3, the value of the starting index will come here. So we copy it like this: 10, 20, 30, 40, 50, and these will be empty spaces. But for this circular array, the starting index will be this one, because we resize by linearizing. You understand?
Yes, ma'am.
Okay. Now, if we resize by keeping the start unchanged, which means that for the new circular array, the starting index will be 3 as well. Now, for this one, when we copy the elements after 10, then the second element is 20, which comes at index number 4. So the next element in this circular array, or the original circular array, was at index 0, which was 30. So do we keep 30 here, or do we keep as it is, like the first, like the initial circular array? What do we do?
Keep it like the initial circular array.
Does everybody agree with that? Do we keep it at index number 5, or keep it like the initial circular array? This is the initial circular array. So when we are copying the values, 10 comes here, 20 comes here. So does 30 come here or in the 0th index?
I think it should go in the 5th index, ma'am.
Yeah, missing.
Why 5th or why 0? What's your logic behind it?
If it goes to 0, the circular array will break, right? Because there should not be any empty spaces in between.
Very good. So it should be in the 5th index. Why? Because again, even if it's a circular, like even if we have increased the size, we have to keep the properties intact. Like the empty spaces will be at the end, right? We cannot keep any empty spaces in between. Like we cannot just keep 30 here. In that case, the 5th position, the 6th index, and the 7th index, they won't have any values. So we won't be able to call it an array or a circular array, because we cannot leave empty spaces before we put another value somewhere else. So of course 30 will come here, then 40 will come here, and then 50 will come here. Does everybody understand why we are not keeping 30 in index number 0?
Ma'am, if we are
Right?
doing this, we might as well keep it at 0. What's the point of like doing?
Like we are doing what? Might as well
If we are
keep it
trying
as
to
0.
like keep it in the form of circular arrays, then we
Mhm.
might as well start at 0.
But that's linearizing, right? So the constraint was we have to keep the start unchanged. When we linearized, we started from 0. That was one way of resizing it. But what if there is a constraint which says that you cannot change the starting index? So that's why we are starting from 3. And if we are starting from 3, we cannot keep 3 empty spaces and put the next value in index number 0, right?
Okay, I get it
That's
now.
the
We
whole
cannot
idea.
change the
Okay.
start index no matter what.
Yeah, yeah. So the constraint was we cannot change the starting index. But if we resized by linearizing, that was the previous example that I showed you, which is we can start from 0. By linearizing, we can resize. That was one way of doing it. There's another way of doing it, which if there's a constraint which says that we cannot change the size, sorry, the starting index, we were starting from 3, and in that case, the next value should be here, not in the 0th index. Do you get it now? And then 40 will come here, 50 will come here.
Miss, can you explain resizing with linearizing again?
Yeah. Resizing with linearizing was the same as converting a circular array into a linear array. So in that case, what we were doing was we first increased the length. We increased the length, and then when we were copying the values, kept the property of a linear array. That means we were starting from the 0th index. So that means 10 would come here, 20 here, 30 here, 40 here, and 50 here. Like we were just copying the values from the starting index of the circular array to the new array's 0th index. This is what we did when we converted a circular array to a linear array, right?
Oh, okay, Miss, I get it now. Yeah,
0th index aspect.
yeah,
So
Miss, I understood.
that's what we are doing it. We are linearizing, we are first resize, and then we were copying the values by linearizing. That is, the starting index is now 0. But if the constraint is we cannot change the starting index, we start from the same index that the initial array was starting from, and then we were copying the values. What we have to keep in mind is we cannot keep empty spaces in between. All right?
Ma'am, shouldn't there be another way to resize? So let's say we increase sort of the second array that we're creating. Instead of creating it of length, let's say 5, let's create length 6, and then right shift all the elements on that side and create an extra room for another element.
Right shift to create an extra room.
Yeah, like create extra room for one more element. If you're
Like
resizing,
how will that help? Let's say I resize. Just like you said that I make an extra space. Let's say I have now 6 spaces. So what you're saying is, like how do I keep the values here?
so if we are to like not keep the start index unchanged, so we can say that the 10 element which is starting at 3, we place it at 4, and then 20 at 5, and then go that way and add another element at index 3.
Do you mean this?
Yeah.
So like how is it helping? In any case, you're copying the values, right?
Yeah, but I was thinking of another way.
Yeah, but in any case, you are creating a new array. You are first copying the values, but the way you are copying the values is you are like shifting it to another place. Like how it's not helping or it's not making it more efficient, right? In any case, you're creating a new array. In any case, you're copying the values and then you're shifting, but shifting without any reason. Do you understand? Like we are not being able to increase the length in the initial array. Like I cannot just make it an array of length 5. We cannot do that, right? In that case, this would have helped. But if we are making a new array in any case, isn't it easier just to copy the values where they are? Like first you're copying and then you're shifting. Did you say that? Or you're saying that when we are copying, then we are keeping like values starting from index 4?
I'm not too sure. I think I've ended up confusing.
Yeah.
So yeah, we'll go with the conventional way.
Yeah. So what you're saying is, like you're doing something extra which is not needed. Like you are doing something unnecessary. Like you do not, you are in any case, you're creating a new array of space 5, or 6, let's say. Right, then you're in any case copying you have to copy the values. Otherwise, what values do we keep here? You keep the values which was in the initial array, right? So we were copying the values by linearizing or keeping the start unchanged. What you are saying is we are starting from a different index, which is also possible. It's no problem. I'm saying if we have constraint like this, then we have to linearize or we have to keep the start unchanged and then copy the values. Is it clear now? Saidu, right? Is
Yeah,
it clear?
ma'am. Yeah.
Okay.
Yes, it is.
Okay. So how do we code this? Do we code it the same way that we did previously? Let's see what will happen. Let's say if I'm starting from K and then I am it starts from I and then goes up to size. And then for the new circular array of K, we were copying circular array of K. And then we were incrementing K by 1 with the length of the initial array. Will this help or not? Like, is this the right way to do it? Let's try tracing it. So we are keeping a variable called K, which is starting from, let's say, 3. So the value at the third index is coming to the new circular array's third index. This is 3, this is also 3. This is becoming 4, so 20 is coming at index number 4. K is becoming 0. Now see that the 0th index is being copied to new circular array's 0th index. That is 30 is coming to new circular array's 0th index, which is not the right way to do it, right? Do you guys understand why it's not working? Because we are modding it by length of the initial circular array, and because of that, after 4, the index is becoming 0, and when we are keeping the same variable for we are tracking both the arrays with the same variable, so 30 is in any case being copied to index 0 of the new circular array. It's not going to 5. Do you understand what the problem here? Everyone?
Yes, ma'am.
Okay, so if we understand the problem, so how can we solve this?
We could keep another variable that we would increment every time.
Yeah, so we can keep another variable which will be used to iterate the new circular array. And when we iterate it, we mod it by length of the new circular array, not the initial one. So in this case, what happens is, so let's say I have K and J now. So when K, they are both 3 at first. This is 3, this is also 3. So K is 3, J is also 3. So that is 10 is being copied to third index. K becomes 4, J becomes 4, 20 comes to fourth index. Now K becomes 0, but J becomes 5 because 5 mod 8 is 5, right? So now 30 is being copied to fifth index. You guys understand? Questions? Confusion? And then K becomes 1, but J becomes 6. So 40 comes to index number 6. That's how we can resize by keeping the start unchanged. We are keeping a separate variable to iterate the new circular array. Is it clear, guys? Just mod করতে চাই দুইটা different length দিয়ে আর কি। Questions?
No, miss.
Sure? Okay. Sure, right? I'm proceeding.
Ma'am, when we are creating this new array, how do we know the size? Like what size we have to create? Because obviously the
Oh,
sizes
so
are
we
changing.
yeah, so we declare it at the first, right? We are declaring a new array which is all the elements are 0 at first, and the length will be more than the initial circular array. Let's say I increment it by 3. This is how we are doing it. We're making a new array which is of length 4. This was of length 5. We are increasing or resizing it by 3 places. So 5 plus 3 becomes 8. We are creating a new array of length 8.
Yeah, but what if, because I'm also like writing code alongside you, and for some reason I just made my initial array absurdly long. So how do I know that how much I have to increment instead of 3, like length plus 3? Is there a precise sort of algorithm?
To you or the requirement the question has. Okay, that's totally up to you. If I just need one more place that I need to insert only one element, I can just resize it by one place, right? Why would I
Okay,
waste
got
the
it.
memory? Correct? So it's totally up to the requirement of the question or requirement of what operation we are trying to do. Okay? Totally depends on that. Okay, next. So the last thing that we'll see for a circular array is insertion. Now for insertion, it's very important that you see this and understand this properly. Because there are some terminologies that you need to know when you even answer theoretical questions in the form of MCQs or in Viva, etc. Okay? So let's say this is a circular array where the question will tell us insert, let's say 50 at position 2. Let's say this is the question. What do we do? First, for insertion, we anyway have to check if the size is less than the length of the array. So we can see that there's an empty space, so we are good to go. We can insert. But when it says insert 50 at position 2, with your understanding, what do we insert here? You tell
No,
me.
it's a position, not
Always
index.
index
Yeah,
1. The position 2 means index 1.
position 2 means index 0, by the way. 0. Okay, we'll come to that. So
And
this
this
is what you have to understand is the difference between actual index and position or offset. They are both the same thing. So we'll come across this term called offset in MCQ questions as well. So what you have to understand is that actual index and position or offset are not the same thing. If it says insert 50 at position 2, we cannot just insert 50 at index number 2. We cannot do that. Position 2 means, or offset 2 means, the distance from the starting index in case of circular arrays. Okay? The distance from the starting index. So position 2 means if you are starting here, this is the 0th position. This is the first position, or the first offset is 1. This is the second position. So we have to insert 50 here. Is everybody clear with this? This is very important for you to understand. Do we understand, or shall I repeat it again? So position or offset means the distance from the starting index. That is, if 3 is our starting index, that is basically the 0th position, or offset is 0. Then the next one is the first position, and then the next one is the second position. So in that case, we have to insert here, 50 here. All right, do you understand the difference between index and position offset? Okay. So if we understand that, now how do we insert? In case of linear array, we used to left shift or right shift to insert? If we right shift or left shift to insert?
Right shift.
Right shift.
Yeah. So for circular arrays, we can either left shift or we can also right shift. Both are acceptable. Now, what will happen if we right shift and what will happen if we left shift? See, if we right shift and then try to insert, what happens is, for right shifting, we always start from the rightmost index. That is, in this case, for circular array, the last index is 1. So we right shift 40 to here, 30 here, and we make space here so that we can insert 50, right? So 40 is coming here, 30 is coming here, and 50 gets inserted here. Understood?
Yes, ma'am, understood.
Okay. What happens when we left shift? So left shift is also allowed because this is a circular array, and we can also insert by left shifting. But in that case, what happens is, for left shift, we start from the leftmost index, that is the starting index. That is, we are left shifting 10 to here, 20 comes here, 30 from 0, it goes to index number 4. That is, if I move 30 towards the left, it will come here, right? And then we make space here. That is, 10 is coming here, 20 here, 30 here. We make space for 50, so we insert 50 and then like that. But for left shifting in circular array, the starting index is changed. It was at 3 first, now it's at 2 because 10 is coming here. So this is what you have to understand it for circular
ম্যাডাম
array.
সার্কুলারে যে 30 40 পর একটা স্পেস রাখছেন, এখানে যদি স্পেস না থাকে এলিমেন্ট থাকতো,
তাহলে তো ইনসার্টই করতে পারতাম না।
ও আচ্ছা
তাহলে
আচ্ছা,
তো রিসাইজ করতে হতো প্রথমে, তাই না? খালি জায়গা না থাকলে তো আমরা প্রথমে ওটা চেক করি যে সাইজ কি লেন্থের সমান নাকি, প্রথমে চেক করে নেই না ইনসার্ট করার সময়। লিনিয়ার অ্যারে তো করতেছিলাম। সো যদি সাইজ আর লেন্থ হচ্ছে সমান হয় তাহলে তো আমরা ইনসার্টই করতে পারবো না, তখন আমাদেরকে ওই যে এই লিনিয়ারাইজ করে বা স্টার্ট আনচেঞ্জ রেখে প্রথমে রিসাইজ করতে হবে, ঠিক আছে? অথবা বলতে হবে যে
একটা
জায়গা
বক্স
খালি নেই।
বানাইতে হবে আর কি।
হ্যাঁ, অথবা বলতে হবে যে জায়গা খালি নেই, ইনসার্ট করতে পারবো না। বাট তারপরে কি, যদি জায়গা খালি থাকে তাহলে তো ইনসার্ট করতেই পারি, ঠিক আছে?
আচ্ছা,
এখন ওই ইনসার্টটা হচ্ছে আমরা হয় রাইট শিফট দিয়ে করতে পারবো অথবা লেফট শিফট দিয়ে করতে পারবো। যদি রাইট শিফট দিয়ে করি তাহলে স্টার্টের কোনো চেঞ্জ হবে না, আমরা জাস্ট হচ্ছে পিছন দিক থেকে রাইট শিফট করে করে ইনসার্ট করতে পারবো। বাট ইফ উই লেফট শিফট, তাহলে হচ্ছে লেফট মোস্ট ভ্যালু, দ্যাট ইজ দ্য স্টার্টিং ইন্ডেক্স, is left shifted towards the left array. So in that case, start gets changed. So for insertion, if we insert by right shift, the start won't change. If we insert by left shift, the start will change. Okay? Questions? No questions?
No, miss.
Okay. So for insertion, we did this. So we can also remove in circular array. So I want you to explore that on your own. For removal as well, we can remove by right shift and we can remove by left shift. But for removal as well, there will be a change in the starting index. But for which one, you can find that out. So what I want you to do with, like on your own, first you try, and then if you face any problems, you tell me. So for insertion, what I want you to do is try inserting with right shift and also left shift. Try removing as well. If you can insert, of course, you will be able to remove. Okay, so try inserting with right shift and left shift. And another problem that I want you to solve is, do you guys know what is a palindrome? I think you have this in your lab assignment as well. Do you understand what is palindrome?
যেটাকে উল্টাইলে ওইটাই হবে ম্যাম।
Yeah, so if I like reverse it, it's the same. Let's say race car. If I write it the opposite way, it's still raised scar. So this is called a palindromic sequence or a palindrome word. So whatever sequence or pattern is the same both ways, that's called a palindrome. So for linear array, it's easy to understand that, let's say 1, 2, 2, 1. This is a palindrome, right? From the start and from reverse color, it's the same. Can you tell me is this a palindrome or not?
No, miss, it's not.
Sure. Does everyone agree that this is not a palindrome?
Palindrome, ma'am. One
For
thing is
circular, it is.
Yeah. So if I consider it, this is a circular array, right? So the start is at 1. So if it starts at 1, of course, the next element is 2, then 3, then 2, then 1. T is a palindrome. Okay? So what I want you to do is try like determining for
Miss, can you
circular.
explain it again why it's palindrome?
Sure. So this is the circular array, right? So for circular array, this is the starting index for the circular array. It's starting from 2. Now, if it's like when we even print circular array, we start print from the first element, right? If this is the starting index, of course the first element is 1, and after that the second element is 3. Then it's the second element is 2. Then the third element is 3. Then circularly, then it's 2, and then it's 1. This is the right way, right? Like we are representing it in array and we are starting from index 2. But when we consider it from the start to the end, this basically looks like this, right? 1, 2, 3, 2, 1. And this is a palindrome.
Yes, miss, I got it.
Okay. So your tasks is to try inserting with right shift and left shift in circular array. And your task is to try finding out a palindromic sequence, if a circular array is palindrome or not. ADT. ঠিক আছে? Questions, anything, confusion from circular array? So you can see that what we learned in the previous class, we are basically using the same thing again and again to do everything else. All right?
There's some confusion in left shift in circular arrays.
You have a confusion? Yeah, please tell me.
Yeah, in the left shifting, yeah. Can you explain that bit?
Yeah. Shall I repeat again?
Yeah, sure.
Okay. So in case of left shifting, let's say if I have an array and 10, 20, 30, and 40, and I have an empty space. So the starting index is at index number 3. So in case of left shifting, basically we shift the elements towards the left, right? Okay. So if I am shifting the elements towards the right to make a space at position number 2, which is index 0, that is, this is the 0th position, first position, and then second position. We are trying to insert the new element here. So in that case, we are left shifting to make a space here. So what we are doing is, for left shifting, we start from the leftmost element. So leftmost element basically means the first element. In this case, it is 3. So we first shift the value at the third index towards the left, then the next towards its left, and for 0, we shift it towards its left. That is basically 30 comes here. So the resulting array looks like 10, 10, 20, and then 30 comes here. Now there's an empty space here, right? So we can easily insert 50 here, and 40 will be wherever it was. But in this case, what happens is the starting index was at 3. As we shifted it towards the left, the starting index now is here. Do you understand now?
Yeah. Yes, sure, miss.
Okay. Sure?
Yes.
All right. Okay, so I forgot to show you one other thing, that if it says position number 2, how can you find out that which index it is? That is, I cannot always start like 0, then 1, and then this is 2. This is not a like efficient way of doing it, right? So for any index, even if it starts from 3, how do we find out which index is position 2? You understand the question, by the way? Like position 2 is index number 0, right? But how do we find that out? If you understood these things, you should be able to tell me this. That what will be the index if position is 2?
We use the same modulus thing. We divide by modulus of length. But this
Yeah,
time
but
we add a different number. So let's say for position 2 we add 3 or 2.
like if the start is 3 and position is 2, how do we find out that the index is 0 in this case? That's the question.
Manual, we try.
Do you guys understand the question? Like whatever array it is, if the question says that we have the starting index defined and the position is 2, we have to insert at position 2. How do we find out which index it is? Anyone? Nishanto, tell me.
Okay.
No? Anyone else?
Can I give it a go?
Okay, go on.
We could like use this formula as position equals to k plus the given position, and the modulus operator by length a.
What is
Length
K
of
here?
the array. K is the starting.
Okay, so basically start.
Yeah.
Plus.
Start plus position. And then modulus of length. Did it work?
Yeah, absolutely. Yeah, absolutely right. So the starting index is 3, position is 2, the length is 5. So 5 mod 5 is 0. So the index will be 0. The index is 0, right?
Yes.
Does everybody understand?
Yes, miss.
Okay. This was Friday, right?
Yes, ma'am.
Okay, you get a bonus point.
Wow.
Acha. Okay, so shall we move on? Does everybody understand circular array? Somewhat understand circular array?
Sure, miss.
Okay. So as we don't have much time, I'll just quickly just give you a heads up regarding linked list, which is our next topic. Okay, so we won't go into depth, just to give you an idea what is linked list, so that you can relate it. Achha. So linked list is basically, do you guys understand a student might have multiple features, right? Student ID, department, name, etc. So this is basically a blueprint of a student, which is a class. And whenever we create a final product out of it, they are objects. That is basically, let's say you guys are like different students, right? So each object will be different. Like each student will have unique ID, department, and separate names. So from a design, we can create multiple objects. So this is the basic idea of classes and objects which you will need to learn linked list. So linked list is basically multiple objects linked together. All right. So this is an object, this is an object, and this is an object. But they are all of the same type, which is popularly known as nodes. That is, this one is a node, this one is a node, this one is a node. What is a node? You guys all have trains, right? You
We're
all
all
know what
nodes. We're all nodes in Facebook, right?
Yeah, you all are nodes in Facebook. So you guys have also you guys know of trains, right? So trains have multiple bogies, and inside the bogies there are passengers, there are your luggages, your suitcases, etc. And one bogie is linked with the next one with a chain, perhaps. So this whole idea, a train, is basically, you can call a train a linked list. And each bogie are called nodes. This is the basic idea of a linked list. Now, what is a node? So node is basically a container which can hold two kinds of values. There are two compartments in a node. The first compartment can hold any types of data, any integer values, any string values, etc. And the next one, or the next compartment, can hold an address. What address? It basically holds the address of the next node that is linked with it. Do you guys understand? Let's say this place, the address of this node is Dhaka, and the address of this node is Chittagong. This has a data, this has a data, and when we are linking it, so Dhaka's, this compartment has Chittagong's address. When we are linking this node with another node, let's say this node is at Khulna. So basically, Chittagong has Khulna's address in this compartment. This also has data, this also has another address. And we can link it, and we can add as many nodes as we like. You guys understand the idea?
Yes.
Okay, so we cannot go from Chittagong to Dhaka, as you can see. Like Chittagong does not hold Dhaka's address. Chittagong can only go from Chittagong to Khulna. Dhaka can only go from Dhaka to Chittagong. Then from Chittagong it can go to Khulna. Okay, so as this is like this can only go one way, this is why this is called a singly linked list. If Chittagong or this node had the previous node address, we would call it a doubly linked list. But we'll come to that later. You don't have to worry about that now. So first, let's understand what is singly linked list. So what do we understand so far? Linked list is basically nodes connected together. So a node has two values. One is a data, one is another node's address. So the address that it's holding is basically another node. So when we implement this in Python, so for Python we do not have to mention the data type, but for other languages we do. But it's very important that you understand the theoretical part as well. If for interviews or vivas, if the interviewer asks you that in a node class, what is the data type of this compartment's value? So it can be integers or string, etc. But the data type of this one is basically another node. You understand that, right?
Yes, miss.
Miss, can you repeat?
Okay, so this is a node class which can hold two values, or it has two compartments. The first value can be of any data types, integer, strings, etc. But the next value holds the address of the next node. That is, in this case, it is holding the address of Chittagong, right, which is the next node. So if the question is, or the interviewer asks you that what is the data type of this one, you say that it's a node.
Oh, okay, Miss. Understood.
Now you can ask is node something built in Python? Or is there like it's like if there's something called node in the languages? No. So node is basically a user-defined class which we will use and create multiple objects of node, and then we will link them together. So that means the node class that we will create will have two attributes. One will be the data or the value, and another will be the next node address, which is another node. So these are the two things the node class will have. Okay. If we understand up to this, I'll just quickly show you the node class. Any questions till now?
No, miss.
Okay. Acha, before jumping into the code, one last thing, the difference between arrays and linked list. So for arrays, we know that we have a fixed capacity, right? Like we cannot keep more than 4 values in this array. The size or the length is fixed. But for linked list, there is no limitation like that. This is array's limitation that we can only keep 4 values here. But for linked list, we can add as many nodes that we like, and we can keep as many data that we like. Okay? So this is one difference between array and linked list. Another difference is when we try to insert an element or we try to remove an element from an array, we do a lot of shifting, right? Personally, I didn't like shifting when I was a student. So shifting basically is very tiring and it's very complicated, I feel. But when we try to insert or when we try to remove an element from a linked list, we do not have to do any kind of shifting. It's very easy. We just insert a node wherever we like. Okay? So this is another difference between arrays and linked list. Questions, anyone? No? Okay.
ম্যাম
What?
আমরা যখন ম্যাম একটা কোশ্চেন ছিল।
বলো।
ম্যাম আমরা যখন কোনো একটা অবজেক্টিভ প্রিন্ট করি তখন ওইটার অ্যাড্রেসটা চলে আসে। আর এখন কি এই যে নোড আমরা যেটা বলতেছি ডেটার পরে যেটা আছে ওইটাতে কি ওই অ্যাড্রেসটা থাকবে, মানে পরের পুরো নোডটার অ্যাড্রেসটা ওইখানে থাকবে?
হ্যাঁ, তুমি যদি নোটটা একটু পরে তোমাদের নোটটা যখন আমরা কোন একটা অবজেক্ট যখন প্রিন্ট করতে যাই, আমরা দেখি না যে একটা হেক্সাডেসিমাল ভ্যালুর মতো একটা অ্যাড্রেস আসে। সো নোট আমি যদি একটা নোডও এরকম প্রিন্ট করতে যাই সেরকমই একটা অ্যাড্রেস আসবে। ঠিক আছে, নোটের জন্য যে অবজেক্টটা আমরা ক্রিয়েট করব সেটা যদি আমরা প্রিন্ট করতে যাই সেটাও কিন্তু একটা অ্যাড্রেসই আসবে। তো আমরা কিন্তু এই নোডের অ্যাড্রেসটাই এখানে হোল্ড করতেছি সেকেন্ড জায়গাটাতে।
ম্যাম আমি বলতে চাচ্ছিলাম সেটা হচ্ছে আমি যদি চিটাগং নোটটা প্রিন্ট করি তাহলে যে অ্যাড্রেসটা পাবো, আমি যদি ঢাকার ডেটার পরে যে জিনিসটা আছে ওইটা প্রিন্ট করি তাহলে কি সেম জিনিসটাই পাবো?
হ্যাঁ, মানে ধরো এটা ধরো n ভ্যারিয়েবল, এটা ধরো n নোড, এটা ধরো n1 নোড। ঠিক আছে, আমি এখন প্রিন্ট করতে চাইলাম n1, I'm printing n1 and I'm printing n এর next যে আছে সে, that is n dot next in printing, that is n and not next, they will both same address হবে। বুঝছি যে n
জি
এর
ম্যাম,
next
বুঝতে
যে
পারছি।
চিটাগং and n1 যে চিটাগং নিজে, both are the same address। Okay?
জি ম্যাম, থ্যাংক ইউ।
Okay. So one last thing, that is, as we were talking about trains, right? The first bogie jeta thake, like whoever operates the train, right? The first bogie, that is. So for arrays, we have something called random access, which is basically if I want to access the value of the third index, I can just directly do this, right? A of 3, and we directly get the value at index 3, right? So we have random access for arrays, but we do not have that in linked list. So linked list, there is no indexing argument. So how do we iterate a linked list, or how do we find out the third bogie or the third node? So what we do is we always refer to the first node as head, and we never move head. So head will always be the first node, and we iterate starting from head. So even if I want to go to the third node, what I have to do is I have to start from head and I have to go here, then here, and then I jump to the third node. I always have to start from the first node. So I do not have random access in linked list, which we had in arrays. So these are the three differences between arrays and linked list. Do you understand?
Yes, miss.
Oh. Sorry, the class is becoming a bit long. Just quickly show you the node class. Achha, do you want me to write it? I showed it in the previous class. Shall I just show it to you here? Achha. So this is basically a node class. We have defined a constructor, and we, just like I said, I have a value and I have a next node's address, which is the next, which we defined it next. Okay, so this is basically the node class. Okay, now if I want to create, let's say, nodes, let's say n1 is the first node, and I keep a value 10, and for now there is nothing in its next compartment. I create another node, which is 20, and then none. I create another node, n3, which has 30, and 4, 20, and then, okay. So what I basically did is I created 4 objects of nodes, or 4 nodes. One is n1, n2, n3, and n4. And in each I get 10 here, I get 20 here, I get 30 here. But is this a linked list? Yes? Like, did I create any links?
No, miss.
Not yet, right? So I have to create links to make it a linked list. So what I do is, for n1, n1 is a nodes object. In its next, I put n2. See if you understand this. What I basically did is, for n1's next, I kept the n2 node here. I created a link between n1 and n2. So n1 now holds the address of the n2 node. Okay? Do you understand?
Yes, miss.
Yes, ma'am.
n2.next is n3. n3.next is n4. We have all the links now. Okay. Now if I want to iterate it, as I said, I always have to start with a variable called, like, here is the first node. So when I try to iterate, what I do is, say I define head. n1 is now the head, and I try to iterate with a iterator called n, and it starts from head. So I have an iterator, which is n. Now I'll have to print the values of, I want to print the values of the linked list. Can you tell me how do I do it? Like, first, when it's at the first node, it will print the value of this node, which is 10. And then it will go here, and then it will print the value of the next node, which is 20. Then it will go here, and then it will go here. How do I understand when to stop? Like, there's no index that will tell me that this is the last index, or this is the length, or so on. So how do I know when to stop? What will be the stopping
The
condition?
next value is
When
none.
self.next is none, ma'am.
Self.next is none. In that case, this won't be printed. When this value becomes none, তখন we will stop. If we keep it like n.next is যতক্ষণ none, so in that case, this value won't be printed. Okay, the last node won't be explored. So what we'll do is, while n is not none, we'll run the loop till when it reaches none. That is, none basically means that a node যেটার পরে আর কোনো node নাই. Okay, so none basically means that there's no node after that. We have a none value, and inside that we print n.value. We understand up to this, right? Now, in case of arrays and whatever, we used to do n equal to n plus 1 when we had integer values. In this case as well, like we do not have indexes. How do we iterate? How n moves from this node to this node, and then this node to this node? How do we move or how do we iterate? We understand where we are starting.
ধরে ধরে মনে হয় যাবে ম্যাম।
হ্যাঁ, so when we know that we are starting from head, we know that we are going up to none. So we basically, one sec, yeah. We basically iterate n and move to the next node with n dot next. So with n dot next, n was here. When n becomes n dot next, n comes here and prints the value of this node. Then n is equal to n dot next, n comes here and prints the value of this node, and so on. What is take?
We have to say node bracket then the node because we're creating an object.
It's a mistake here. Thank you. Yeah, as we are creating objects, we have to set them as. Okay. So for 10, then 20, and then 30, and then 40. Is everybody clear?
Yes, ma'am.
Yes, ma'am.
Okay. So yeah, we'll only keep up to this today. Sorry, it was a long class. So I hope there's no more questions. So the next day we'll learn. We won't do this manually. As you can see, I created 4 nodes manually and then linked one to another. So it won't be feasible or efficient if we have, hundreds of nodes and so on. So this is just a manual way so that you understand how they are linked. So in the next class, we'll see that we already know that how to create a node class. In the next class, we'll see how we can create the linked list class, and inside the linked list class, we'll create objects of the node and then link them together. We will see how we can, put elements of an array and copy them to a linked list and etc. All right. So I hope there's no questions for today. Anything, guys?
No, miss.
Yes. Oh, so quickly give